All right, welcome back. Hopefully you took a little bit of break and got away from it for a little bit prior to us kind of going on here. And we're not going to look at this. We're just going to do a few more examples, and then we're going to do one more example of what you've kind of been looking at, just to give you one more chance at doing the X method. And then we're going to go on and do a little bit more in-depth problems. Okay, so we've got 2x squared plus 3x plus 2. Rewrite it without a highlighter, probably. That would help. 2x squared minus 3x minus 2 equals 0. X method, got -4 and -3. So -4 and 1. So we've got x minus 4, x plus 1 equals 0. A value is 2, so since my a value is 2, make sure you divide and reduce. So that's x minus 2. Doesn't reduce, so that's 2x plus 1. Now we have to find the zeros. What makes that 0? 2. What makes that 0? -1/2. So those are your zeros. And we're going to use all this eventually to help us graph these a little bit more accurately. I think that's probably the next a couple steps down the line, but is really taking these and graphing them a whole lot more accurately by using the zeros as well. All right, so now let's look at a couple of applied problems. At least we're going to look at one big one, and then you can do kind of what you want. So a multi-level driving range has 3 levels. Marco hits a golf ball from the second level, which is 32 feet high. The height of the ball x seconds after Marco hits is modeled by the function. So you're given the function. When does the ball hit the ground? Okay, so if we think about how this goes, we're kind of standing here. Marco is standing here. He's going to throw the ball. The ball is going to do something like that. We want to know when the ball hits the ground. So essentially, if we're thinking about this as a coordinate, we want to know when it hits the x-axis being the ground. And everything is already taken into account with the formula. Okay, the formula is taking care of how high he is when he's throwing it. Okay, because he's throwing it from the second level. So he's throwing it from 32 feet high. So he's like throwing it from up here, not down at the ground level. He's up here throwing this ball. So this part of the graph doesn't really exist, and he's not standing down there. He's standing on that second level. So we just need to figure out when this thing is going to hit the ground. So we're going to find its zeros. So 16x squared plus 16x plus 32. We want to figure out when that thing is equal to 0. Now here's where you've got to make sure you do taking out GCFs first. I don't know what that pause is about. A little crink in my neck. I don't remember I'm talking to a phone right now. That's all I see is a phone and this little screen in front of me. I'm as bored as you are doing this. I promise. Okay, I don't promise. But yeah, I agree. It's not much fun. Sorry. It's what we're doing. It's what we have to do at this point. Nothing I can do about it. I don't know if you can hear me or not. I'm see how much time I can waste. Okay, I'm done. Okay, so we have to take out a GCF, and I like my A value to be positive if possible. So I'm going to take out a GCF. I'm going to take out a -16 because that goes into all of them. If I take out a -16, that leaves me with x squared plus x plus 2 equals 0. Okay. Now, the -16, we ain't going to worry about it. It's just going to kind of come along because we're going to factor. So this one's not so bad to factor, so we're just going to kind of skip the whole x method thing. Or does it even factor? Oh, shoot. See what I did wrong here? Made a common error that happens in here, and I made the error. So let's go back to here. See, you distracted me when I was doing nothing and doing whatever. All right, so I made the common error that happens when you do these. So we're taking out a -16. So since we're taking out a -16, we got to divide all of these by -16.
So if I take negative 16x squared divided by x, that just gives me x squared. If I take 16x divided by negative 16, that actually gives me negative x. And if I take 32 divided by negative 16, that actually gives me negative 2. So there's taking out that GCF. And again, we don't need to worry about that negative 16. Just have to be careful for it. I made the mistake too. I just brought the signs down. So make sure you're a little bit careful with that error. And now we're going to go ahead and factor. And part of the reason why I noticed it, that I did it wrong, was that I couldn't factor it. What I had before, there was no way to factor that. And I knew we wanted to be able to factor. So we've got x and x. We've got a minus, so that means one's going to be a minus, one's going to be a plus. We have to be minus 2, so it's minus 2 plus 1. So now we find the zeros. So then when you're finding the zeros, what makes this 0? 2 makes this 0. What makes this 0? Negative 1. They want to know, when does the ball hit the ground? Well, it doesn't make sense for the ball to hit ground after time in the past. So after 2 seconds, this ball is going to hit the ground. And actually, we could find a whole bunch of things if we wanted to. We could find the axis of symmetry. We could find the vertex. We could find all of those things if we wanted to. And eventually, we're going to want to. Okay. Let's look at the next one. So a ball is thrown from the height of an upper deck of a stadium, 128 feet above the ground. The function, f of x is equal to negative 16x squared plus 32x plus 128 gives the height of the ball. X seconds after it is thrown, how long will it take the ball to hit the ground? Okay. Press pause at this point. Go ahead and do the problem. When you're done, unpause it. Okay, so I just kind of worked through it as you were kind of what it looks like, and you get x is equal to 4. Okay, so now we've taken and we were able to find the zeros. Now we're able to apply them. We're able to find those zeros. Now, all right. I took a little pause in there, I think. I don't know. So now we want to be able to write equations of these. So just like we did the other day when we were talking about when we had to use that 3 by 3 variable matrix, we're going to do that same thing. We're going to write equations, IHS. But it's not as hard. So remember the general form from the first part of this lesson. The general form of a quadratic in factored form is y is equal to a times x minus p times x minus q, where p and q are your zeros. So our zeros are kind of sitting right there. So we're going to replace our p. So the first thing we're going to do is we're going to replace those p's and q's with our zeros when we're solving this problem. So that's kind of the first step in here, is we're going to take and we're going to replace the p's with our 0, and we're going to replace the q with our 0. I'm going to simplify that, and hopefully you see the little trick. I'm not going to tell you what it is. If you see it, you see it. If you don't, you don't. So there's what it looks like. So now we know, gosh dang, so now we know that it has to go through the point negative 320. So since we have that point, we can take our equation and fill in our y values and our x values. We know our y value is going to be 20, so I'm going to replace that with a 20. We're going to find the a value. That's kind of our goal here. The x value is negative 3. So we've got negative 3 plus 2. So I'm just going to kind of do it along here. Negative 3, that's just negative 1. And then this is going to be negative 3 plus 1, which is negative 2. So this gives us 20 is equal to negative 2 or positive 2a. So divide both sides by, so you get our a value is equal to 10. Now we can rewrite our equation, and this is our original equation we started out with. Now we know the a value. So when we rewrite that, then we're just going to rewrite that equation with the a value in there. So a is equal to 10 times x plus 2 times x plus 1. And we're okay with this form today. There's nothing wrong with that. Is it a great form? No. Could we move that and put it into standard form? Yep, we could. Could we put it into vertex form? Yep. Will we? Possibly. Not today. Okay, so there's the first one. Go ahead and see how much you remember. See if you can do this one by yourself. Press pause. And then when you come back, hit play. And I'm not going to speak through it. I'll just kind of, just go. So there you go. So there is your equation of a parabola with the x-intercepts and the y that passes through that point. So there's section 2.3, factored form of a quadratic function. This video has taken me forever. I've had phone calls, I've had mistakes. I think it's time for me to be done for the day. Stay safe, everybody. We will talk to you next time.